Chapter 7.2, use the converse of the Pythagorean theorem. All right, just some notes before we begin. If you have a number underneath the square root, let's say you have radical x, and you square that, you basically just remove the square root. So if you have the square root of x and you square it, that's just x. All right, so let's say you have the square root of 17, and you square that. Well, you just remove the radical symbol, and that's 17. All right, so that's the first thing you need to know. Now, if you have two numbers multiplied by each other, let's say you have x times y, and you square that, that squared actually gets distributed to both terms. So if you have x times y and you square the whole product, that's going to be x squared times y squared. All right. Just as an example, let's say you have 3 radical 6, and you square that. Well, you have to square each one of those individually. All right. So the squared gets applied to the 3. So that's going to be 3 squared. And the squared also gets applied to the radical 6. So that's going to be radical 6 squared. All right. 3 squared is just 9. Radical 6 squared, we said before, you just remove the radical. So radical 6 squared is just 6. And 9 times 6 is 54. All right, so if you have a number and a radical squared, make sure you square each one individually and then multiply them. All right, so this is the converse of the Pythagorean theorem. It just says if the square of the length of the longest side is equal to the sum of the squares of the two lengths of the other sides, then the triangle is a right triangle. The bottom line is this. If c squared equals a squared plus b squared, then ABC is going to be a right triangle. Okay, so if you have side lengths of a triangle, you have to test this theorem out. And if it works, then it's a right triangle if you have the side lengths. All right, and you want to remember when you have the side lengths, you're always going to use C as the longest side. All right, so when you have your 3 side lengths, A, B, and C, just make sure you use C as your longest side. Example 1, tell whether the given triangle is a right triangle. All right, so we have the triangle here, and we have our side lengths. All right, we want to prove it's a right triangle, and we want to do c squared versus a squared plus b squared. Okay, I like to do it on a table. You don't have to do it in table form like this, okay, but I think it helps. Now, from the picture or diagram, we can clearly see which one is the longest. But in some cases, you might not know which one is the longest. You might have to square each one first. So let's do that, okay? We're going to square each side first and see what happens. All right, so if you do 9 squared, that's just 81. And if you do 15 squared, that's going to be 225. 15 times 15. And finally, if you do 3 radical 34 squared, remember, when you square it, you have to square each one individually. So that's going to be 3 squared times radical 34 squared. Okay, and let me see. 3 squared, or 3 times 3, is going to be 9. Radical 34 squared, you just remove the radical, so that's 34. And 9 times 34 is going to be 270 plus 36, that's going to be 306. So now that we squared each side, we know which one is going to be used for C, or C squared. All right. We can clearly see out of the 3 numbers, this one is the longest. So we're going to make this one C squared because that's the longest. A and B, it doesn't matter which is which. So we can let the 81 be the A squared. All right, and we can let the 225 be the B squared. But those two don't matter. C squared has to be the longest. So on the chart for C squared, I'm going to do 306. I already squared it. And for A squared plus B squared, I'm going to do 81 plus 225. All right, so 80 plus 225, that's going to be 305, plus 1, that's going to be 306. All right, and we can see that 306 equals 306. All right, those are equal. So the answer is yes. It's a right triangle. All right, so that's how you prove it. And like I said, sometimes when you have something like this, you won't know if it's the longest or not. So you might want to square each side first and then put them on the chart. But we got the same value on both sides. So yes, it's a right triangle. C squared equals A squared plus B squared. All right, you don't have to use the chart, but that seems to be the best way to explain it. All right, guided practice. Tell whether the triangle with the given side lengths is a right triangle. All right, please try number 1. And like I said, I suggest you square each side first. All right, we have our chart here, our table. Let's square each one of these so we can put them on the table. First, we'll start with the 4. We know 4 squared, or 4 times 4, is just 16. And 4 radical, well, we'll do the 8 squared. 8 squared is just 64. 8 times 8. And if we do 4 radical 3 and square it, that's equivalent to 4 squared times radical 3 squared. You have to do each one individually. 4 times 4 is 16. Radical 3 squared, you just remove the radical. And 16 times 3 is 48. All right, so we have our side length squared. Which one of these is C squared? The longest one. That's going to be 64. A and B, it doesn't matter which is which, so I'll let 16 be the A squared, and I'll let 48 be the B squared. All right, so for C squared, I'm going to write 64. For A squared, I'm going to write 16. And for B squared, I'm going to write 48. 58 plus 6, that's 64. So once again, it checks out. And the answer is yes. It is a right triangle. All right, and that's because a squared plus c squared equals a squared plus b squared. All right, so continuing on, if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. All right, so if c squared is less than a squared plus b squared, it's going to be acute. So that means for acute, that means all angles acute. All right, and what is acute? Less than 90. All right, so you still do the same chart, but if you get c squared is less than, a squared plus b squared, that's going to be acute. All right, all angles in the triangle are acute or less than 90. All right, if the square of the length of the longest side of the triangle is greater than the sum of the squares, then the triangle is obtuse. All right, so if c squared is greater than a squared plus b squared, then it's going to be obtuse. All right, and for the obtuse triangle, that just means one angle is obtuse. And what is obtuse? Greater than 90. All right, so if c squared is less than, it's going to be acute. All angles are acute, less than 90. And if c squared is greater than, it's going to be obtuse. The one angle is obtuse or greater than 90. So why is acute all angles acute and obtuse is only one angle obtuse? Well, if you had more than one angle obtuse, the angles would be greater than 180. All right, remember the angles inside of a triangle have to add to 180. So for an obtuse triangle, it's really only one angle is obtuse. Like in this one right here, we could see this is obtuse. All right, and this makes sense. You can really just figure this out. If you start with a right triangle, okay, and you have your hypotenuse. You don't have to write this just yet, but if you start, well, you can write it. I'll write it twice. If you start with a right triangle and you make the hypotenuse, if you make the hypotenuse shorter, that angle that was a right angle is also going to get smaller. Okay? So if this is shorter, let's say this was the hypotenuse was 7, and then I make the hypotenuse 5. This angle right here, instead of being a right angle, that's going to get smaller because this angle here closes up if this side is going to be shorter. All right, so this angle becomes acute. All right, and the same thing is true with the obtuse triangle. Let's say you start, once again, you start with a right triangle. This is a right triangle. And you will go across from the right angle. Again, that's your hypotenuse. And again, we can just make it 7. All right, and let's say I make a new triangle. And I make the side length longer. All right, instead of 7, let's say I make this side length 9. Now, if the hypotenuse gets longer, the angle across from the hypotenuse is also going to get bigger. So instead of being a right angle, it's going to be obtuse. All right, so remember your hypotenuse is C. And if you make that side shorter or longer, it's going to change the angle. If you make the C shorter, the angle becomes acute. The angle closes up. And if you have the hypotenuse C again, and you make the angle, the hypotenuse longer, the angle is going to open up and get bigger. So then it's obtuse. All right, so if it's C squared is greater, it's going to be obtuse. If C squared is less, it's going to be acute. All right, example 2. Can segments with lengths of 4.3, 5.2, and 6.1 form a triangle? If so, is the triangle acute, right, or obtuse? All right, so in the other examples, it was already given that it was a triangle. On this one here, first they ask if it's actually a triangle, and then if it's acute, right, or obtuse. All right, so in the first case, for the first question, we have to use the inequality theorem. The triangle inequality theorem. If you remember, in order to test if the side lengths actually form a triangle, okay, these are the side lengths right here. In order to test that, we have to add the two shortest and make sure it's greater than the longest. All right, so that's what you have to do here first. All right, the two shortest are going to be 4.3 and 5.2. All right, so 4.3 plus 5.2. And make sure it's greater than 6.1. 6.1 is the longest side. Now, again, just like we did in the past, if you want to do all three calculations and make sure the sum of any two is greater than the third side, that's fine. But I like to use the shortcut. All right, so we're trying to see if this is true. 4.3 plus 5.2 is going to be 9.5. And is 9.5 greater than 6.1? Yes. All right, so far, so good. All right, so we got that part out of the way. And now we want to see if it's acute, right, or obtuse. So as always, we're going to use the table. And we're going to do C squared versus A squared plus B squared. All right. Now, you don't always have to square them first. In this case, we can clearly see the 6.1 is going to be the longest. But I like to do it that way. This way, you don't forget to square them. Some students, they take these numbers and put it right on the table, and they don't square it. So this is part of the reason I square it first. Okay, so we're going to do 4.3 squared. We're going to do 5.2 squared. And we're going to do 6.1 squared. All right, I'm going to do each of these on my calculator. All right, I squared each one. I did not have to round off, and this is what I got. So which one is going to be the C squared? Well, the longest one is always your C squared. So that's 37.21. And we said for A and B, it doesn't matter. So I'll let 1849 be the A squared. All right, 18.49. And I'll let 2704 be the B squared. So that's going to be plus 27.04. All right, so 2704 plus 18.49, I get 45.53. All right, so which one is less? We're doing this versus that. Well, 3721 is clearly less than 45.53. All right, which means the c squared is less than the a squared plus b squared. All right, and we said when the hypotenuse shrinks, when the c squared is less than, that's going to be acute. All right, so when the c squared is less than, it's acute. If it was greater than, if the c squared was greater than, it would have been obtuse. And if the c squared was equal, it would have been a right triangle. All right, please pause and try the same thing on number 23. All right, so we're going to start with the inequality theorem to prove it's a triangle. All right, you want to do the two shortest and make sure it's greater than the longest side. So the two shortest are going to be 8.2 and 4.1. So we're going to do 8.2 plus 4.1. And make sure it's greater than the longest, 12.2. 8.2 plus 4.1 is 12.3. Is that greater than 12.2? Yes. So we can continue. If it was no, then we would just stop right there and say that it's not even a triangle. All right, so as always, we're going to do c squared versus a squared plus b squared. All right, so let's see if we square each side first. Let me see if I have room here. I'll do it down here. We're going to do 8.2 squared. We're going to do 4.1 squared. And we're going to do 12.2 squared. All right, so I'll do each one of these on the calculator. All right, I squared each one. I didn't have to round. So you look for the longest one, and that is going to be your c squared. All right, so 148.84 is my c squared. All right, the other two, it doesn't matter. 67.24. Plus 16.81. All right, let's see. 148.84 is your c squared. Adding these two, 4 and 1 is 5. 2 and 8 is 10, carry the 1. 13, 14, carry the 1, and that's 8. So which side is greater? Well, we can clearly see 148.84. Let me erase this bar in the middle. We can clearly see 148.84 is greater than 8405. So c squared is going to be greater than a squared plus b squared. And we said when c squared was greater, that means the hypotenuse got longer. That makes the angle get bigger. And that is going to be obtuse. So that is number 23. So in this section here, you don't have to do the inequality theorem. We can see it's already a triangle. Okay, in the next section here, it says the given side lengths of a triangle. So you don't have to test the inequality theorem. But then in this section right here, it says first decide if the segment lengths form a triangle, then determine if it's acute, right, or obtuse. So only in this section is where you're doing the two steps. All right, and I'll give you a little hint on number 16 and 17. If you want to test the inequality theorem here, you have to do six times radical 43 on the calculator. Okay, and then you could round off. All right, so let's do that real quick. All right, if I do 6 times the square root of 43, 6 times radical 43, and hit equals, if I round this decimal off, this is going to be 39.3. All right, so this right here is 39.3. So if I wanted to do the inequality test on number 17, all I would do is add the two smallest one, 24 plus 30, and make sure it's greater than 39.3. All right, and I can see in my head, this is 54 and this is 39.3, so this is definitely true. All right, once you prove that step, then you can go on to the other step and do c squared versus a squared plus b squared. All right, but that's a little shortcut for that problem right there.